Hello everyone. Today we're going to talk about how to design utilities using composite curves. What we want to do is to select the utility or combination of utilities optimized for the problem and fix the most suitable operating parameters and quantities, levels of temperature and enthalpy flows. The pinch analysis techniques that we are studying and the composite curves on the temperature versus delta H diagram can be used for this design. This is because utilities are no more than hot or cold stream, exactly equal as process stream. As an example, we're going to use the composite curve to introduce an intermediate level of steam. Imagine, for example, that our problem is being heated with just one high pressure level steam and the boiler has broken. Then we want to buy a new one and we are wondering if a two-level steam boiler will be better for our process. Then, how much steam from the new level can we use and how this will affect the original stream? Well, the thing is simple. We introduce a new hot stream with the medium pressure steam, the new level, and left the high pressure steam, the old one, in place. As we are changing the extension of the medium pressure steam, the extension of the high pressure steam is also affected. And we can even go to the appearance of a utility pinch, the use of the maximum utility at this level in such a way that the hot stream arrives to the minimum approaching temperature. This is the maximum amount of medium pressure steam we can use. Of course, we can do that because an energy stream is exactly like any other. It has its level, thermal inertia, duty, like any other hot or cold stream included in the hot or cold composite curve. Another example. We want to generate steam from boiler feed water, recovering heat from the process. How much steam at a given T can be generated starting from boiler feed water at ambient temperature? If this results working, we're gonna buy a heat recovery steam generator and put it in place. This is a more complicated case because this is a combined utility. You have two chunks, two parts of this utility. The preheating from boiler feed water to saturated liquid and the vaporization. Both parts are linked by the mass flow rate you want to generate. This is the sensible part, the sensible enthalpy flow, and the vaporization enthalpy flow. Both parts give us the total enthalpy flow we get from the process. Then, as the quantity of steam generated increases, the extension of this stream increases also, and the angle in the middle of this utility increases. Then you see in this example, you can reach a utility pinch before in the low level part of the preheating than in the higher part of the evaporation. As you can see, by trying and error, we can design this utility using the composite curves. A last example, dimensioning a gas turbine cogeneration. How much can we cool the flue gases from the turbine? Or, what is the same, what is the minimum mass flow rate of flue gases required for the process? Because the mass flow rate fixes the slope of this stream. Okay, the mechanism is the same. We're gonna try with a quantity, constructing the modified composite curves till we arrive to a utility pinch. Checking at the same time that as the stack, the condensation of the flue gases doesn't happen. Then you can see the design, the calculation of utilities is possible using the composite curve, but no easy. It's a question of trying and error.